Welcome to this new webinar. This is our third webinar for our free FEM civil course. Thank you for attending. Some of you have been asking some questions regarding the software, and some of them are, first of all, how to configure the license, the HUD selection tool, how to define a contact pair, and clipping planes and listings. Some of these capabilities are already explained in the free course videos. They are available in the playlist of YouTube. They are all in the virtual platform, but we will explain them again today. First of all, the configuration of the license. If you go to the software installation section, there are two ways of getting the software. The first one is starting right now the course. You can get 1 month of the full commercial CivilFEM 2020. You must send this file, the host ID utility that it's available in the classroom. Send it to this email, and you will receive 2 files. Once you have these 2 files, I will explain it later how to configure your license. But if you already have used this commercial version, then your 1 month license has expired. Then you can get in this website the student version, and it will last forever. The only difference between the commercial and the student version is just the limit of nodes, because the capabilities are full in the student version. You can use everything available, but only take into account that when meshing you will have a limit of 5,000 nodes. If you open, once you have the 2 files, if you open the administration utility, you will have this window, and you have 2 files. That file, which is the MSc licensing, the DAT extension, and the LIC extension for CivilFEM. You just need to copy and paste, or adding here the license, but always take into account that you must have the full path here, okay? And then save changes and exit. If everything is okay, you can open the software and work with no problem when meshing and solving. I'll show you these capabilities using this example, which is available as well in the classroom. This is the definition of a footing with two alternatives, with and without a strap beam. We have defined first the geometry of the soil, and then different geometries, but we want to, you will see later, to connect the mesh of the different entities. This is the HUD window, the HUD toolbar, which can be activated here in the View tab, and this is a selection tool. We have the different main types of selection of geometry, structural elements, and contacts. If it's highlighted the geometry mode, then we have these 4 options: selection of points, curves, surfaces, and volumes. If we unselect or we just leave highlighted points, it means that we can only select define points, and if only surfaces or only volumes. I have to activate first all of them. You can see that if it's only depending on the ones selected here, we can select them as well in the entity window. But if we have activated the selection of structural elements in the HUD, the selection of the different structural elements by finite elements, by nodes, you can see here the numbering, and here you can activate the graphical selection of model utils if you have defined some of them. Okay, but we have no model utils defined. So this is how the HUD tool works. Very useful for selection of entities. So how to define a contact? Here in this example, we have defined two types of contacts, with or without friction, and if we want to join dissimilar meshes. As you can see, we have three main structural elements, which is the soil, the foundations, and columns, and the mesh is not congruent. You can see that the mesh, the nodes are not connected. So we can, to connect the mesh, if we want to continuity in results, we must connect the mesh in many things. We can perform a congruent mesh and then use the merging of nodes, or it can be easier if you don't want to spend time modifying your mesh, is defining a contact pair. If we want to just join the column and the foundation, once we have this window of the definition of the contact pair, we can set the name, choose one of the elements, then if we want to go to the next contacting structural element, we must go to the next property using this arrow. So we have two different solid elements here, and now I have my contact pair. Okay, if we define our contact, I can do it again now with this one here and this one. Without clicking the arrow, you will see that it will replace the first structural element, but what we want is to create a contact pair between the column and the foundation. To do that, once the first structural element is selected, click here, and we have it here. As you can see, we have defined already these ones. These ones are the contacted, and the contacting are the foundations. We can define the contact of columns and foundation in one glue contact pair, and we have defined another contact with different properties. It's not a glue contact. In this case, it's a touching contact, and we have set a friction coefficient between the foundation, both of the foundations, and the soil. To do that is the same. Select first the contacted and the contacting. You can do it here. Choose with the Control key pressed. We have our two foundations. We go to the next property, and we just click the soil, and we have the final contact here. There's another option in the HUD toolbar, which is the how to view the contacts. As you can see here, Now we have the contact of footing and soil, so we can check if it's well defined, and the columns and footing. In blue, the contacted, and in green, the contacting. Here you can see. Okay. Well, if you solve this, it will turn into a nonlinear analysis because of the contact definition, and because of that, you will have different plot cases. You can check any type of results. Now in the 2020, we have different types of solutions divided into different groups. We can check the total displacement. Here you can see that these entities were glued, so there's no separation between them, but the foundation and the soil are not glued. They can be separated, and a friction was defined. So you can see that this footing is sliding. You have to always take into account here the scale, because this is not a real scale. You can set it to real scale. You can see which is because the structure will not move as big as we have seen before. But here you can have an idea of the deformed, the final deformed shape. Well, if you check the exercise, you will see that after performing here another strap beam, you will avoid this big displacement and stresses in the footing. Okay. And another type of results are the clipping planes. Well, not the type of result, but how to view results, internal results, which can be here in the clipping. You can activate it here in the view utils, and here you can see internal results using the clipping options. Very useful when you have solid elements defined. And as well, some of you have asked how to list results. It's very easy, just depending on the result that it's available here in the result time and results and the units. Just go here and you can list all results or just a selection. I just pick this structural element, and here we have the list of total displacement. But of course, you can change other type of result and list it here. Okay. Very useful here to check is the contact stress or contact status, to check if the contact pair are working as well. So these are some of the utilities that are explained now. If you have more questions, you can place them in the utility. You can use the chat if you want. I can continue with the presentation. Just, well, you know that the 2020 version is already available. Here are some of the improvements. If you want to perform or improve your knowledge in your FEM basics, you have the UNED course. The registration will start in this September, and now you are enroll in the free FEM course. Thank you for your participation, because we already have 3,000 students. And if you want to go further and enroll to the advanced FEM course, which is a very special price, and with the length of this course is 2 months, and will cover different topics. We will hold a new webinar presenting with more details this advanced course, but here are some of the contents, because you know that CivilFEM has a lot of tools, and they need to be explained with more time. Some of them are covered already in the free FEM course, but others will be explained in this advanced civil course. Activation and deactivation for construction stage, seepage, more geotechnical capabilities, including slope stability and seepage, dynamic analysis. Many other examples will be explained. Just to mention that the IngeCyber performs as well consulting project. Get information always in our webpage. Thank you very much for attending.